In June 2026, Anthropic released Claude Fable 5. It launched with benchmark-setting performance and breakthrough capabilities that established a new standard for artificial intelligence. Exactly 48 hours later, a jailbreaker known as Pliny the Liberator bypassed the model's security. Pliny extracted the model's system prompt, 120,000 characters of hidden instructions. This document contains the model's behavioral guidelines, strict prohibitions, and even motivational pep talks designed to boost its accuracy. The leak revealed the machinery behind the intelligence, a massive human-written instruction manual governing every output the AI produces. Writing these instructions is now a high-stakes profession. Bloomberg reported in 2026 that tech companies are offering up to $335,000 in annual compensation for principal prompt engineers. According to the 2026 Stack Overflow Developer Survey, prompt engineering is at the top of the list of critical skill gaps. It currently outranks distributed systems, Kubernetes, and security in terms of market demand. A 3% drop in performance on a complex coding benchmark can cost a company millions in compute time. In a production environment, an optimized prompt represents the difference between a mediocre tool and a top-tier product. Developers use the leaked prompts from Claude and Cursor as technical documentation, studying them to understand how models actually process human intent. Research in early 2026 confirms modern models suffer from context overload. Feed the system too much raw data without prioritization, its reasoning performance degrades. Engineering has shifted away from writing verbose paragraphs. The current objective is ruthless data compression, delivering the necessary information without triggering a collapse in model accuracy. To manage this sensitivity to overload, engineers developed a structured architecture for human-machine communication. This architecture uses 4 layers: system, developer, context, and user. Isolating instructions ensures the model understands its role before seeing the request. This separation enables prompt caching. The first 3 layers remain static across requests, bypassing repetitive processing and cutting API costs by 90%. Prompt engineers use chain-of-thought techniques to force sequential reasoning, requiring the AI to document logic steps before answering. For complex tasks, a tree-of-thoughts approach explores multiple parallel reasoning paths simultaneously, selecting the most optimal solution. These rigid structural patterns have transformed prompting into a measurable engineering science, defined by data structures rather than linguistic trial and error. This reliance on reasoning creates a fundamental security flaw. Large language models treat all text in their context window as potential instructions, making them vulnerable to malicious commands hidden inside legitimate data. In 2026, researchers from Noma Labs exploited this flaw in the GitLost Attack. They successfully bypassed the automated security scanners in GitHub's agentic workflows. The attack hid a single command: ignore previous instructions, inside a file name. When the AI reviewed the repository, it read the file name as a high-priority rule and followed it, allowing malicious code to pass security checks. The linguistic flexibility required to solve a complex coding problem is the specific surface area an attacker needs to hijack the entire system. Organizations are currently shifting towards constitutional AI, training models with hard-coded ethical principles, and automated testing frameworks that evaluate thousands of prompt variants per second. The gap between skilled and unskilled users is widening. GitHub research indicates that developers in the top quartile of prompt engineering skills are 55% more productive than those at the bottom. Large language models function as a high-speed multiplier, accelerating the output of the engineers who know how to guide them. The democratization of AI does not mean a democratization of capability. Mastering the internal language of these machines has become the defining dividing line for the future of the workforce.